Okay, so in this video, we are going to look at a built-in data type for Python, which is the one we are going to deal with most. So this is called strings. So as we know, when we handle text, we can treat text as strings. Okay, so Python is actually a very easy to use language because it has this built-in data types or data structures we can use, and also so these data types or data structures, they come with appropriate operations. Okay, so now let's take a look here. Python is an easy to use general purpose programming language. Okay, so the good thing about this is that we don't need to declare variables as in C or other languages that you use. And also we don't need to compile the application. We just need, so we can just run each line of code when you write it, because Python is uses an interpreter. So you can read some of the things over. So for more explanations, so you can read it yourself. So now we are going to jump into string types right away. Okay, so here, string types, so because we can use a double quote. For instance, I'm creating a string, I call it new underscore str. So I'm going to say I am creating a string. So this is a sentence, and because there is a single quote here, so I cannot use a single quote here to confuse it. So I'm going to use a double quote. So this I am creating a string. So I am creating another string. So this is a different variable. As you can see here, we don't need to declare any variable. We just go ahead and use it. So now I'm going to print the ID for this new string. So ID will be the memory location or the address on your local machine. So these, of course, I already run these things. So now maybe I will just clear them up so we can run it again. So one way to clear everything up is that you go to, I think, go to kernel. So we can restart and cleared output. So which means that I'm going to restart and clear all the outputs. So as you can see, all the outputs are gone. Okay, so now we're going to do it. So we run this. So as you can see, here is the memory location for this first variable new underscore str. For the second is this, and then we print the value, right? So we print, so this is the type is a string, and then we print the value itself. So value for new string, so which is the sentence. So sentence itself is the value of that variable. So as I'm creating a string, I'm creating another string, right? So the next one would be how we are going to connect different words together. So for instance, I have a hello, I have a world, exclamation, and also I have a space here. So I want to glue them together, right? So hello world, and here I am a simple string. So we glue them together, we can use plus, and then this whole, so this is a simple string will be just a hello world, and then I'm a simple string. So now we can just run it to see what it looks like. Hello world, I'm a simple string, right? So the next one is now I'm creating a multi-line string. As we said last time, we use a triple quotes. Okay, so we have used triple double quotes or triple single quote. They actually do the same thing. So in this case, okay, so just run it. So here you can see that the carriage return is printed because this actually has a carriage return here, although you can't see from this definition, but it's actually there. So this is the carriage return. And this is another carriage return. Okay, so that's what it is. And then we can print them. If you use a print, then of course you won't see this carriage return. So then this is what's intended. Hello, I am a multi-line string, right? Exactly like this. Okay, and then the next one, we're going to set a path. So now we can do a input and output. So here I have a file name called file.txt. So I'm going to input that one. Okay, so now when I print this path, this is the, you see this is the folder. So what's basically using this path is not a good way to do it, right? So this is a, when you have an escape sequence, so that will lead to a wrong file path. So instead, okay, we are going to use this. So raw string keeping the backslashes in its normal form. So this is what we want to use. Okay, so now we get the whole thing up. And then we are going to look at unit codes. So this is a Unicode. So this is hello, right? So, but now we have an accent. So for this E, now I have little accent here. And also I may have some other Unicode symbol. So this is a pizza, this is car. So now we can print more Unicode and you can actually print them out. So this is actually a character. So Unicode has a lot of different characters that, because we don't have those in English. Okay. So this is one way. And then we can print, for instance, we can print string with Unicode plus more Unicode. So we print these two together. So then you can see, so now we have these two together. And also we can join them, right? So we put these two into a new data structure. Now the things you see here is that we got a new data type. So now this is a new string. We have a quote here. When you print them, when you print this, you don't have a quote. So you see here, we don't have a quote. So that you can just play them, play these things yourself, right? So here we're going to, for instance, we can print. So this is a whole string, but we can, so more underscore Unicodes is more, yeah, is this. So if I want to print a certain characters at certain locations, so the one way we specify is the star location. And this is, so this is 5. So 5 really prints the 5ths to 9s. Okay, so this is the upper bound -1 is where you want to print. And then of course the index starts from 0. So this is those of you who use the C, you know that the index starts from 0. So for this, I get order, right? And then for this, for the 19th character, let's see what it looks like. Okay, it is the pizza sign. So you can count this, it should be just the 19th character. And then this is the -16 means you start from the right end and you go back by 16 places. So that is the it shouldn't be. Yeah, so we get this out. Okay. So you may wonder, okay, if I do it by one place. So we can just add one. Sometimes you can say, okay, you can play with it, right? So just like this one, what it looks like. Oh, more Unicode. hello. So I type this wrong. So it should be this. So that's the question marks because it's the first one at the right hand side. So that is this. Okay. And so for this is in reverse order. So you particularly need to remember this thing. So which means that this prints the whole string in the reverse order, right? So this is the reverse order. Okay. So, and then there's another way is to handle Unicode graphemes, right? So for instance, this is what the Unicode, so this is the Unicode, so what it looks like. Well, it is a coffee, right? So, and of course, we can also get its code, which looks like this. This is a UTF score -8 code, but if we want to get its Unicode, so this is the way we get. So we get the same thing as this, right? So this is the command we do. So this is the code. This is the character. Now think of these icon. Think of these icons as characters. So we want to look at their code. So instead of looking at UTF-8, I want to use this standard kind of Unicode graphemes. So this is what it looks like, right? So this is another example. Okay, so you print, so you print this, and this, of course, it will give you this thing, the pizza icon. All right, so now let's look at string operations. We already looked at plus earlier, so we just add them up into a single string. Okay, so, and then we can also use this. Let's see what it looks like here. So this is the same thing. So instead of using plus, we just glue them up. Okay, I don't have concatenation. So this is extra. We don't need it. So I should put this sign into here as a concatenation. Concatenation means you put several strings together into a new string. So this is no longer useful. So this is another one. So now we define a string called S1, which is Python. And this looks like a icon for a computer. And then I'm going to glue them. I'm going to concatenate hello with this icon plus S1, right? So that looks like this. Okay, so this is another one. So we do S2, and then this times 5 means we repeat this 5 times. So that's what it looks like. And this is concatenate S1 and S2. So S1 is Python with the terminal, and then this is, right? So you do times 3 means repeat it 3 times. So these are some small tricks, right? So this is, so the next one is we're going to define a, so this is parentheses. So parentheses is sort of like a new string, right? So this is another way to concatenate several strings together. So this is one string, another string, another string. We put them together, put the parentheses here, and that's a new string, okay? So there is no executable. So we checking for substrings in the string. So maybe we put these here, because that's what it is. Okay, so we don't need this, so we cut that. So now we have this, we run it. So that's true because this S3 contains this word way. Okay, how about Python in S3? So we check this, there is no Python, so it's return false. And then the length, right? So this is the length. Let's again put it here. So I'm gonna delete this. So this is length x3. So length x3, you can count the number of characters. Of course, we can just ask the Python to compute, to count this for us. So there are 51 characters. How about these two? Okay, so this is length. Make a guess. 3, because 1, 2, 3, 3 characters, right? So each of these icons is considered 1 character. Bar, and then this, right? Smiling face. So now let's look at string indexing and slicing. Okay, so for this, let's say we use a for loop. So for loop, of course, we have a string s. So s is defined earlier. Let's go way back. Well, forgot what it is, so you can just print it out to see what it is, right? So let's just print it out so we can insert, because we already forgot what it is, but I want to know what it is. Let's print it. Okay, so I didn't define, so this is not defined. So I must have somewhere defined it. So let's see, this cannot run, right? So this doesn't run. And let's say I change it because S is not defined. So let's change it to a new word. Let's say S3. And I can define. So there's a character T is index 0, H1, and so on. So we get all of these. And then this is gone because it's not defined. So now we have this S3. So in order to avoid changing all of these, so maybe I would just say S is 3. So that I can bring them up. So the first one, right? So the first one is 0. That's capital T. So what we get, THIS space I, right? So that is the first 6 of them. Likewise, if you do the reverse order, so that's the exclamation sign. So that is here, right? You do ISG for how many? So that is 6, right? You go back 2, 1, 2, 3, 4, 5, 6. You go to R here. Okay, so that's what it is. Slicing, of course, means a substring of a string. For instance, this is the entire string, and then this 1 to 4 would be the first to the third. Now remember, the index starts from 0, so that will be HIS. Right, so that's what it is. And then of course you can go ahead and run these things. So this is a substring, and this is a reverse order. Okay, starting. Okay, from the last, but you count 3 times. So exclamation S and G. So that is what it is here, right? Okay, so the last 3 in the order, GS exclamation signs, then you this is glue them together. right? So now you can play with this and string slicing with offset. So this is no offset, but if you change 1 to 2, then of course you will jump 1 character. So this, the second, so TH as H, every other one is now, it's removed. Every other character now it's removed from this string. So that's what this offset is. For this, there is no offset, right? So if you say, how about I change to 3, and of course you can change it to 3 and then run it. And that's what it looks like, right? So string immutability. So for instance, if we, let's say I have change, well, substitute the first one to X. Okay, so does not support item assignment, which of course gives you an error, right? We already predicted it. But now what you can do here is that if you want to change that, you want to use this. So first of all, I get a list. So you change string to a list. Once you have a list, then you can do an assignment to change it. So that's what it looks like. So the T, capital T now changed to capital X. So you convert a string into a list. From there, you can do this assignment, and then you converted this back to a string. So that's what it is, right? So join. So this function join means now I'm going to create a new string. Right, so this is some small tricks and case conversions. For instance, small case, you want to capitalize it. So use this function capital, and then everything is the first word, so it's a capitalize a sentence, right? So, but if you want to change every letter into a uppercase, then you use upper. And if it's a title just means that every word, the first letter of every word, except the, for instance, except A, in, that kind of thing, would be capitalized, right? So this is the title. And then next, we're going to look at how we replace a string. So for instance, I want to replace Python with NLP. Okay, so in the sentence S, right? S here is a Python is great. I replace Python with NLP, so NLP is great. Numeric checks. I want to know whether a string represents a numerical value. So in this case, of course, it is true, but in this case, of course, you know it's not going to be true, right? Because the Apollo 1, because it's not, so this is a 1, right? So this is L, this is 1, Apollo 1 is not, you look at the whole thing, is not numerical value, even though 1 is a numerical value. Okay, and then we want to change whether it's alphabet checks, right? Alphabet. So this is true because Python is, but number 1, of course, even though number is alphabetic, but 1 isn't. So this should be returned false. Okay, alphanumeric means a combined both. Now this one doesn't have. Well, this is a alpha. This is alphanumeric, so this also should return true. But this is not because 1 plus 1 plus is not alpha numeric, so it is false. And then we have a string splitting. So splitting a string using split, right? So we already see this earlier. So you segment these strings into a sequence of words. Okay, and we can put them together. So so we put them back together using this. So this is using a join function. So this is join each of these words into with a empty string. So that of course you add something. So you add something one by one at the end. So you get a new string to a empty string, right? Okay, so and then string formatting. So for instance, you can hello, and then you put this percent s, and this is percent. Let's see what it is. So we basically, so this string now, I can put whatever value here into this place, right? So this is a for string. So then I can put two, right? So SS here. So that way I can place a world, how are you, into this world, into this place, how are you, into this place. Okay, so these are small tricks, and you can take a look at these things. So you can always come back to look them up if you forget, right? So another thing that's new is about regular expression. So regular expression is some kind of pattern that represents a whole bunch of string, right? So to do so, for instance, let's first define two strings, S1 and S2, and then we use a library called RE. So that is regular expression. So then we look at the pattern, which is a Python. Okay, and then we will print whether this S1 contains a Python, because this Python is now really my regular expression. None of them, because the sentence doesn't have Python. Small case, right? So small case. Now, if you change to capital case, then it has a match, right? So this is the first part. So remember, the index starts from 0. So 0, 1, 2, 3, 4, 5, right? Remember the 6, the upper bound will be always subtract 1. So we found a match. So let me put the small case back. Don't find anything. Okay, and then we're going to say we're going to match a pattern. So this is small. This is a Python S1 flag. So now let's say we want to, so we do match. So this one means that we are going to ignore the case, right? So Python before, because this is a case sensitive, now we indicate we want to make it case insensitive. So now we have a match. Okay, so this is some other examples that you can take a look yourself by playing with them. Then you'll get an idea. So as I said, that you don't need to remember these. You can always come back, right? So then putting all together. So this is how we're going to how we're going to process text and analyze them. So this is, again, we're going to import NLTK. We already talked about this NLTK earlier, and then we want to download this particular vocabulary. Okay, it would take a while because the vocabulary usually is a little bit big. Okay, so now it's done. And then we want to see, I want to do a 9 chart. Okay, so so for this, we really get to, so this is the Bible, and so we want to do, so it's not a 9 chart, so it's an inline, so there's a map plot lib, so it's inline. So what we get here is we got the King James Bible, the Old Testament. So this is what the first 5, so Bible, the first 5. So this is the output, right? So it looks like the, so you want to change it. Let's say we'll change to 1. Okay, so that's the first one. And then you change 2. Okay, then you got this carriage return means you got an empty 9. You got this. So that's how you play with it. Then you got the second sentence, and then you change it to 4. You got another empty 9, right? So right here, and then you change 5. And you got the third sentence. You may wonder what would be the first 10 lines looks like. So that's what the first 10 lines looks like. So as you can see, that Python really provides a lot of tools for us to process data. So now let's see how many lines in Bible. You have these many lines. Okay, so then you can play with the. Oops, it's already done. How many words? Let's say total. Okay, let's run this. So now we can do a plug, right? So, so sentence. Where is my sentence? So this is okay. So this is Bible, of course, is now a sequence of sentences, right? So we look at the first 10 sentences, and then for each sentence, we are going to look for how many words in that sentence. So this is total tokens per 9, right? So, and this is a list, so which means that I have, for instance, I can print. Let's print this to see what it looks like. Print total length per 9. Now this is a list. Now this is just a sequence of items. So it's going to be a lot, right? So it's going to be almost about 100,000 lines. It will be a lot of them, right? So this is the token. So the token just means that how many tokens per 9. For instance, for each 9, at the first 9, I have 4 tokens. Now we can go back here. The King James Bible, that's 4. Okay, so the second 9, there is no token, that's 0. The third, which is the first book of Moses called Genesis. So there are 5, let's see, 1, 2, 3, 4, 5, 6, 7, and also here there's a punctuation, so that's considered as a token. So this one has 8 tokens, right? So then, of course, we want to know how long, right? So we want to do a statistics to see how many lines we'll have, for instance, in this, how many lines we'll have about 2 tokens, they're quite a bit. Well, and here about 12 tokens, right? So this is 17 tokens, and so that's a lot of those. There's a lot of short ones, right? So that's how we can get an idea of these sentence lengths in the Bible. So of course, this is going to be big, right? So it's about 100,000 lines. So we're not going to see through all of those. And the next one. Okay, so for word in sentence, okay, so let's print this. Okay, so tokens is not defined in tokens. Where do I need to define them? Yeah, it is defined. I didn't run this thing yet. So let's run it. Okay, so now we can run this now. All right, so this is, so that is, right? So this is the, so we can see how many words in the, so we can see how many words, right? So we can say print length words. So this words is a list of all the words, right? So how many words in this Bible? It's almost 821,000, about that. So, right, so this is how many words there are in the whole Bible. Okay. So then we are going to filter out the ones that, so there's A to Z, right? So there's a regular expression. For each word, we're going to so maybe this is what we want to filter. So let's first look at the first 20 words, just right here, right? So the King James Bible, to see what's the difference here, then you would know what we filter out. Okay, so Book of Moses. Okay, you see this. We filter out. So we filter out non-alphanumeric. So there's a capital and small cases. If they are not any of those, we're gonna remove it. So there's one column one is removed, and then the next one will be in, right? So if you want to check it whether the next one's in, so you change to this, see what it looks like. So that's in, right? So then, of course, after this is removed, you get this in here. Okay, so let's change it back. Okay, so now we collect from collection import, so which means that collections here is also a library. Okay, so we get this collection, we count, so this means that the word there appears times and these many times. So these are the words, of course, they frequently appear. This is the top 10. So maybe you can say, how about top 20? Oops. What they look like. So this is the top 20. So again, still this is they're not, we usually call these words stop words. Let's say top 100, see whether we get something meaningful. Yeah, we probably get something meaningful now. Israel, right? So this is no longer a stop word. The other ones still are children, right? So children appears this many times. Okay, so that's how we get an idea of a book or of a text file. So the entire Bible, first of all, it is a sequence of lines, and then we can study how many lines, and for each line, for each sentence, how many a sequence of sentences. So for each sentence, how many words, and in there, right? So now let's do counting. So the top 10 most count, we already done that. So this is, I think this is the repeat for words. So this is not in stop words. Okay, so here, the stop words is the NLTK standard ones. Okay, so these are not the stop words. So this is the, for instance, some of these are stop words. The is a stop word, and is a stop word. So because those stop words are not really interesting, they just for the language itself, not for the, they just use those stop words to link the words together to be grammatical. So if we can remove them, then we can see the actual meaningful words, okay, by removing stop words. All right, so this is a quick introduction about using strings to handle text. So that's it. See you next time.